Welcome everyone to Summary Shorts. And in this lecture, what we're going to do is unfold a very interesting concept in analysis, which is the notion of cardinality of sets. Cardinality of sets. And typically speaking, we have learned that sets are of two types: either it's a finite set or it's an infinite set. Okay, but nevertheless there is a better classification of sets in terms of whether we are able to count or enumerate. A more technical term is enumerate the terms, the elements in the set or not. Okay, and this brings us to very important classification of sets, which are a sort of more general than this classification, which is called a set being countable or uncountable. And the best way to have a visual notion of what countable sets and uncountable sets means is that in case of countable sets, you can somehow distinctly identify the elements. Okay, so in some sense you can think this to be what we call a discrete set, sort of a discrete set. For example, the natural numbers is countable, any finite set is countable, in fact the rationals is countable as well, the integers is also countable. While uncountability is another term for uncountability is what we call the continuum, and these are the indiscrete sets. Sets which are more complicated and they look like a line. You cannot distinctly say that these are only forms of elements which are present in this set. For example, you can distinctly say that the elements in Q are of the form P by Q, right? You can say the elements in natural numbers easily, you can identify them very easily, but you cannot say that for a real number. The reals are uncountable. The closed interval 0 1 is uncountable. And typically speaking, a function, if there exists a function from some set A to n such that f is a bijection, then we say that the set A is countable. And if A is furthermore finite, then we say that A is finite simply, while if it's countable but infinite, we say it to be countably infinite. Thank you. So we understood three classifications, rather two: countable and uncountable sets.